Chapter 3: Common Test Types and Test Process for Mobile Application. 3.1 Common Test Types Applicable for Mobile Application. 3.1.1 Installability Testing. Testers need to focus on installation, update, and deinstallation of the app using the following approaches. Application stores. The installation process may be different depending on the users of the app. The users could install the app from marketplace stores such as the Google Play Store or Apple's App Store. The users of enterprise apps will be required to perform installation tests via a link or distribution service such as Hockey App or App Center. Sideloading, copying and installing app. Some operating systems provide the option of installing the application by copying it to a mobile device and installing it from the file. Desktop applications. Desktop applications such as Apple iTunes for iOS or Android App Installer are available for installing apps on the smartphone. The tester needs to download the app in this application and use a cable to install it from there to the smartphone. Most of these desktop applications also allow deinstallation of the app. Installation can be performed using the following methods: OTA, over the air, via Wi-Fi or cellular data. Data cable. Some of the test conditions that can be considered include installation, deinstallation and upgrade on internal and external memory, if supported. Reinstallation of app when the Retain App Data option was chosen during the previous deinstallation. Reinstallation of the app when the Retain App Data option was not chosen during the previous deinstallation. Cancelling or interrupting the installation or deinstallation, for example, by shutting down the mobile device during the process or disconnecting from the internet. Resuming interrupted installation, deinstallation and upgrade after cancelling or interrupting. Permissions-related testing. For example, some apps request permission to use the address book. This important test must verify app behavior if the user denies permission. For example, is there a corresponding message sent to the user? Update the app and verify that no data is lost. Some apps require jailbroken for iOS devices or rooted for Android devices, which give the user the administrative rights over the device. Most platform providers do not support jailbreaking or rooting, as it may have legal consequences. An app not requiring jailbreaking or rooting may not need to be tested for the jailbreaking or rooting devices. 3.1.2 Stress testing. Stress testing is focused on determining the performance efficiency of the application when subjected to conditions beyond normal load. The stress test in this context is targeted only at the mobile device. Stress tests of the back-end are described in the ISTQB performance testing syllabus, ISTQB CTFL PT 2018, so that further information can be referenced there as needed. Some of the test conditions that can be considered for stress testing include high CPU usage, out of memory, low disk space, battery stress, failures, poor bandwidth, very high number of user interactions. Real-world network conditions may need to be simulated for this. Some of these stressful conditions can be created using tools such as Monkey. This is a command line tool that runs over the ADB shell command line, or, if possible, manually, e.g., by using big files or other apps with high CPU usage or memory consumption. 3.1.3 Security testing. Since security testing is a complex topic, the ISTQB has a separate specialist syllabus on this subject, ISTQB CTAL SEC 2016. Principal security issues for mobile apps include access to sensitive data on the device, unencrypted information transfer or unsafe storage. Some of the test conditions that can be considered for security testing include testing inputs for code injection and overflow, encryption of transferred data, encryption of locally stored data, deletion of temporary data after use or after an abnormal end, clearing text in password fields. Top 10 mobile-related vulnerabilities from the Open Web Application Security Project, OWASP, should also be explored. 3.1.4 Performance testing. If the user installs the app and it does not appear fast enough, e.g. less than or equal to 3 seconds, it may get deinstalled in favor of another alternative app. Time and resource consumption aspects are important success factors for an app, and performance testing is carried out to measure these aspects. Performance efficiency needs to be tested on the device itself in addition to interaction with the back-end system and other mobile devices. Performance testing of the whole system should be performed as defined in the test strategy and is not mobile-specific. Please refer to the ISTQB Specialist Syllabus on Performance Testing, ISTQB CTF-LPT 2018, for further details. The performance test of the app itself should contain chronometry for the most important workflows. Some examples for the workflows of an online banking app are login, change address, or bank transfer with PIN and TAN. The tester should then compare this chronometry with similar apps. Besides chronometric measures, it's important to consider the perceived performance by the user. User experience can have a huge impact on how long the user is willing to wait for a certain function to complete. 3.1.5 Usability testing. Usability is very important for mobile apps because data shows that a large number of users deinstall their apps within a few minutes of installing because of poor usability or performance. Due to this, it is recommended that user experience (UX) design considers the look and feel of the platform which the app is to be used on. If the UX does not conform with the user's expectations for their platform of choice, it can have a strong negative impact. Thus, a tester should be aware of the look and feel on the platform used. Usability tests can be conducted by a tester using various available heuristics and test tools. Considering personas is also a helpful support for usability testing. If required, a usability lab can also be used for this purpose. In projects, findings identified during the usability test are mostly just findings and not defects. The tester must have the ability to explain the findings to the team, product owner, or similar stakeholders. To achieve satisfactory usability, an app should be self-explanatory and intuitive. Allow user mistakes. Be consistent in wording and behavior. Abide by the design guidelines of the platforms. Make needed information visible and reachable in each screen size and type. Please refer to the ISTQB Specialist Syllabus in Usability Testing, ISTQB FLUT 2018, for further details. 3.1.6 Database testing. Many apps need to store data locally using various data storage mechanisms, such as flat files or databases. Some of the test conditions to be considered for the database testing of mobile apps include validation of data storage issues, synchronization, upload conflicts, data security, constraints on the data, CRUD, create, read, update, delete functionality, search, data integration testing for data provided by the device, e.g. contacts, or by third-party apps, e.g. pictures, videos, and messages. Performance of storing the data on the device. 3.1.7 globalization and localization testing. Internationalization, I-18N, or globalization testing of the application includes testing an app for different locations, formats for dates, numbers and currency, and replacing actual strings with pseudo-strings. Localization, L10N, testing includes the testing of an app with localized strings, images and workflows for a particular region. For example, Russian and German words could be much longer than those in other languages. Since mobile devices have different screen sizes and resolutions, limited screen sizes may lead to problems with translated strings. These issues should be checked as standard globalization or localization tests. A very important aspect to be checked is the date format used, such as year, month, day, or day, month, year. 3.1.8 Accessibility testing. Accessibility testing is performed to determine the ease by which users with disabilities can use a component or system. For mobile apps, this can be done using device accessibility settings and testing the app for each setting. Accessibility guidelines are available from platform vendors, and these should be used. For example, both Google and Apple have published accessibility guidelines for their respective platforms. Taking feedback from people who require accessibility is also helpful. For mobile web, an accessibility guide has been published by the W3C, which should be considered. 3.2 Additional test levels applicable for mobile applications. In addition to the usual levels of testing, from component through acceptance testing described in ISTQB CTFL 2018, there is also a need for additional test levels for mobile application testing. 3.2.1 Field testing. Some mobile applications need field testing to ensure that they function correctly in the expected usage scenario for real users. This could include testing on various networks and on different types of communication technologies such as Wi-Fi or cellular data. Field tests should include the use of mobile towers, network, Wi-Fi and cellular data switching while the app is in use. Tests should be performed with varying download speeds and signal strengths, and include the handling of blind spots. Field testing requires careful planning and the identification of all items required to perform the tests, such as appropriate device types, Wi-Fi, cellular data plans on various carriers, and access to various modes of transport required to give adequate coverage. In addition, the routes and modes of transport and the time of the day when the tests are to be executed need to be scheduled. Usability of an app is another important aspect that needs to be covered while conducting field testing. Tests should incorporate environmental factors such as temperature and similar conditions related to usage scenario. 3.2.2 Testing for application store approval and post-release testing. Before an app is sent for publishing, some checklist or base tests must be passed to assure the approval of the application stores. If the release is an upgrade, then upgrade-related tests should also be run. Checklists are typically based on guidelines, such as those specific to operating systems, for user interface design, and for using the libraries and APIs provided by application stores. The approval process may take some time after submission. If any issues are found during the approval process, a new version may need to be submitted, which will require additional time to resolve. This situation requires careful consideration during project planning and testing. A further level of testing is post-release testing. Testing at this level includes downloading and installing the application from application stores. 3.3 Experience-based testing techniques. 3.3.1 Personas and Mnemonics. Personas are fictional characters which represent real customers. They have motivations, expectations, problems, habits, and goals, and it helps to use them when real user behavior needs to be mimicked. A persona could have a name, gender, age, income, an educational background, and a location. In a mobile context, they may use other apps, check their mobile device X times an hour, and can have other devices and personal traits. A mnemonic is a memory aid to remember something. In the context of testing, every letter in a mnemonic stands for a technique, a testing method, or a focal point for testing. An example of a mnemonic is SFIDPOT, S-F-I-D-P-O-T. Letters in the mnemonic have the following meanings. S. Structure, e.g., user interface elements, other application elements, and their order and call hierarchy. F. Function, e.g., desired features are working available and functioning according to the requirements, etc. I. Input, e.g., all required inputs are available and processed as they should be, such as inputs from the keyboard, sensors, and camera. D. Data, e.g., the data is stored also on SD card, modified, added, and deleted as defined in the requirements. P. Platform, e.g., the specific operating system functions are available depending on device settings. Includes store for downloading the app. O. Operations, e.g., the activities of the normal user are available, such as moving between mobile carrier networks and Wi-Fi. T. Time, e.g., handling and display of time zones, time and dates. A mnemonic and heuristic specifically dealing with mobile is I sliced up fun. Letters in the mnemonic have the following meanings. I. Input. S. Store. L. Location. I. Interactions and interruptions. C. Communication. E. Ergonomics. D. Data. U. Usability. P. Platform. F. Function. U. User scenarios. N. Network. 3.3.2 Heuristics. A heuristic approach is a rule of thumb approach to problem solving, learning, and discovery that employs a practical method. This does not guarantee to be optimal or perfect, but can be considered as sufficient for achieving the immediate goals. There are many heuristics for mobile testing. Most mnemonics can be used as heuristics, but not every heuristic is a mnemonic. 3.3.3 Tours. Tours are used in exploratory testing to enable an application to be explored from a specific point of view and focus. They can be performed to understand how an application works and to create models for the workflow. Tours provide an effective method for field testing. An example of a tour is the landmark tour, where a user mimics the visits of a tourist in a city by going to well-known landmarks. The following table shows how visits made on the tour can be used as analogies for the steps to follow in mobile testing. Visits in the landmark tour. The historical quarter. Analogy for mobile testing. Legacy code. Visits in the landmark tour. The business district rush hour. Analogy for mobile testing. Business logic of the app startup and shutdown. Visits in the landmark tour. The tourist quarter. Analogy for mobile testing. Part of the app used by newcomers. Visits in the landmark tour. The hotel quarter. Analogy for mobile testing. Parts of the app which are only active in sleep mode. Combining session-based testing, see section 3.3.4 with tours, including the use of heuristics and mnemonics, helps in enhancing the effectiveness of mobile application testing. The following table shows some good examples of tours for app testing and the areas they cover for giving testing ideas. On the left column, tour for app testing. On the right column, subject covered. Supermodel, look and feel and usability. Landmark, the most important features in the app. Sabotage, robustness. Feature, new features. Scenario, whole workflow in the app in combination with user stories. Connectivity, connectivity used such as Wi-Fi, GSM. Location, correct language, dates, numbers. Light, visibility in different lighting conditions such as dark, outside, red light. Low battery, data losses in the app caused by low energy levels. On the left column, further tours for app testing. On the right column, subject covered in KOHL 17. Gesture, use all gestures wherever possible. Orientation, change orientation. Change your mind, go back. Motion, do various types of movements. Location, move around. Connectivity, change connection types or locations by moving. Comparison, compare with other type of devices. Consistency, check consistency of screens, GUI. 3.3.4 Session-Based Test Management, SBTM. Session-Based Test Management, SBTM, enables exploratory testing to be managed in a time-boxed fashion. A session consists of 3 tasks: session setup, test design and execution, issue investigation and reporting. SBTM typically uses a session sheet containing a test charter that provides test objectives. Additionally, the session sheet is used to document the test execution activities carried out. Exploratory testing is an experience-based test technique which can be an effective approach for testing mobile applications. 3.4 Mobile Test Process and Approaches. 3.4.1 Test Process. The main activities of the ISTQB test process are described in ISTQB CTFL 2018 and are also applicable to mobile application testing. There are additional aspects which are specific to mobile testing which should always be considered as part of the ISTQB test process. Left column, main group of activities in the test process. Middle column, typical areas to consider for mobile testing. Right column, syllabus reference. Test planning, device combination that need to be tested, use of mobile emulators and mobile simulators as part of the test environment, special challenges in mobile app testing, test types specifically required for mobile application testing. Section 4.3, Section 1.7, Section 3.2. Analysis and design. App stores approval testing, field testing, device compatibility, kind of labs to be used. Test types specifically required for mobile application testing. Section 3.2.2, Section 3.2.1, Section 3.2. Test implementation and test execution. Field testing, download and installability post-release testing, experience-based techniques. Section 3.2.1, Section 3.1.1, ISTQB CTFL 2018. Test implementation and test execution. Tests are based on platform guidelines for the user interface and the application stores. Tests based on guidelines will typically be run by the platform providers for their application store approval process. It is recommended to run these as application provider before handing over to the platform providers in order to avoid possible rejection. 3.4.2 Test Approaches. Mobile application testing includes activities to be performed by developers as well as testers. Determining the appropriate depth of testing per test level i.e. component test, integration test, system test, field test, application store approval, post-release, and user acceptance test, are important for delivering good quality products. The depth of testing needed per test level depends on many factors, such as app architecture, app complexity, and intended user audience. Mobile development platforms provide a variety of tools to support testing at the various levels. Understanding the tools and how they can be applied at a given level are very important. For example, a mobile simulator and/or mobile emulator can be used at the component testing level if there is a need to take advantage of the platform-provided framework and instrumentation APIs. In addition, mobile simulators and/or mobile emulators can be used at the system testing level when actual devices are not available. This enables testing for functionality, limited aspects of usability, as well as the user interface. Furthermore, early implementation can serve as a key point to ensure that the devices are set up correctly and all the prerequisites for the execution will be met on time. Unit and integration tests are also important, as well as manual testing, especially in the field testing stage. It is very common for mobile apps to flip the test pyramid. This means that there can be many manual tests.